Section 6.3 Elimination. Essential question. How do you determine what to eliminate in a system of equations? So just a reminder, our three methods for solving a system of equations include graphing, substitution, and elimination. You now know how to graph, which we did in 6.1. You know how to do substitution, which we did in 6.2. And now we're going to do elimination in 6.3 and 6.4. But keep in mind, it's three different ways to do the same thing. You're getting to the same answer no matter which method you choose. Just a reminder real quick about the number of solutions for the various systems. If you have parallel lines, you end up with no solutions. If two lines are parallel, they have the same slope, but different y-intercepts. If two lines are intersecting, there is one solution, and they have different slopes. And if two lines are identical, there are infinitely many solutions. And since they're the exact same line, they have the same slope and the same y-intercept. All right, here's the new stuff. Use elimination to solve the system of equations. So you'll notice the difference between these equations and the ones we've dealt with already is in graphing, we had both equations say y equals. Neither of these equations say y equals, so we don't want to graph. In substitution, we looked for a variable all by itself on one side. We don't have a variable all by itself on one side. We have x and y on the same side, x and y on the same side. So when both of our variables are on the same side for both equations, we want to do something called elimination. Now, in order to eliminate something, we're looking for opposites, or what can make 0 in our equation. So 4 and 3, if I added those together, they would make 7. 6 and negative 6, those would make 0. 32 and 3, if I added them up, would make 35. So the one that made 0 was 6 and negative 6. So you're really looking for a number and its opposite. And they have to have the same variable. You can't combine things if they don't have the same variable. So now we just add vertically. 4x and 3x make 7x. 32 and 3, they're both positive, so they'll make 35. You just look at the sign in front of the number. Now I can easily solve this by breaking up my couple and dividing both sides by 7, and I'm left with x equals 5. Now remember, this is only half of your answer. Just like in substitution, you have to go back in and plug it into one of the original equations. Now you can really choose either equation. It doesn't matter which one, but we have to look for the one with x because we're plugging 5 in for x. So we're either going to plug x into the top equation or the bottom. I'll choose the top equation. 4 times 5 plus 6y equals 32. So all I did was replace x with 5. Now I'll simplify from here. 4 times 5 is 20. And now it's just a couple and third wheel problem. 6y is my couple, 20 is my third wheel. So I'll subtract 20 on both sides. And break up my couple, dividing both sides by 6. And I'm left with y equals 2. So the coordinate point where these lines would intersect is 5, 2. So my answer is intersecting one solution at 5, 2. If I did elimination for substitution for this, I'd get the same answer, 5, 2. If I graphed these equations, you would get the same answer, 5, 2. They'd intersect at 5, 2. All right, same thing. So you'll notice again that we have x and y on the same side in both equations. So we're going to look for something we can eliminate. If x and y are on the same side in both equations, we want to do elimination. So negative 4x and positive 4x is where we make 0. So I'm just going to exit out. My first step is always to put a big X through part of my system, the part that ends up being 0. So now we have a positive 3 and a negative 5. Positive 3 and negative 5 make negative 2. Negative 3 and 5 make positive 2. So you have to keep in mind, you have to look at what the signs are in front of the numbers. Now I can easily break up my couple by dividing both sides by negative 2. And I'm left with y equals negative 1. Making sure you have the correct signs is very important, because if you plug negative 1 in for y and solve, you're going to get a very different answer than if you plug positive 1 in for y. So be careful about those signs. I'm going to take negative 1 and plug it into that top y. So I've got negative 4x plus 3 times negative 1 equals negative 3. Train tracks, and then I'm going to simplify from there. So 3 times negative 1 is negative 3. And then I'm just going to do couple and third wheel. So negative 4x is my couple. Add 3 on both sides. 4x equals negative 3 and 3 make 0. I can still divide both sides by 4. 0 divided by any number is 0. So my coordinate point where these lines would intersect if I graphed them is 0, negative 1. This is my solution. Intersecting one solution, 0, negative 1. Remember, we always have to write the x coordinate first, then the y coordinate. All right. Again, I have x and y on the same side, x and y on the same side. So that's now I know I want to do elimination. Now, it may help you on this one to put ones in front of all of our variables. That's going to make this one a little bit easier. So look for where we make a 0, and that would be 1 and negative 1 make 0. So I'll put my big X through the 0. Then 1x and 1x make 2x. That's why putting the 1s is kind of important there, because a lot of people say x and just write x. But 1x and another 1x make 2x. 7 and 9 make 16. Divide both sides by 2. And I'm left with x equals 8. So this is half of my answer. Don't stop there. Now I'm going to take this x and plug it in here. If you want to put the ones there again, if it helps you, you can. 1 times 8 plus 1y equals 7. 8 times 1 is 8 plus y or 1y. My couple is y, so mine is 8 on both sides. I'm left with y equals negative 1. So my coordinate point is 8, negative 1. This is intersecting one solution at the coordinate point 8, negative 1. All right, now we've got a word problem. The sum of two numbers is 47. The difference is 13. Find the numbers. Now I'm going to tell you a couple tricks here. This word problem has 3 sentences. Since we've been dealing with systems of equations, we know we're going to need 2 equations. The first sentence is going to give us that first equation. So let's see what we can pick out of that first equation. Well, I know the word sum means to add. And I know the word is means equals. So I'm going to put a plus sign and an equal sign. I know I need those. Well, if you notice, what's right after the word is, or the equal sign, is 47. So we'll put the 47 there. Now it says the sum of 2 numbers. We don't know what the 2 numbers are, so we've got to assign them variables. We know they're 2 different numbers, though, so let's do x and y. So now I'm going to move this a little closer so we've got one equation ready to go here. Okay, our second equation is going to come from the difference is 13. Well, difference means to subtract, is equals, and then we've got our 13. So the difference of the numbers, so that means if I subtract x and y, I end up with 13. So there are my 2 equations. Now it says find the numbers, so that means I need to solve. So I'll draw my train tracks. Again, since this is a problem with x's and y's, you can put 1's in front of them if you want to. 1 and -1 make 0, so that's where I'm going to put my big X. X and X make 2X, or 1X and 1X make 2X. 47 and 13 make 60. Solve my equation by dividing by 2. X equals 30. Now I'm going to take 30 and plug it in for X. So I'll do it in the top equation. 30 plus Y equals 47, minus 30 on both sides, y equals 13. So my coordinate point, and you don't actually, on a word problem like this, you don't have to name it as a coordinate point. They just want to know, find the numbers. What are my numbers? My numbers are 30 and 13. So you really don't have to list it as a coordinate point for a word problem like this. If you wanted to, you could. But they just want to know what are the two numbers. Summary. The homework for this lesson is page 352, numbers 5, 7 through 10, 15 through 17, and 19 through 20.